Beyond the edge of the universe lies a question that has stirred the minds and hearts of dreamers and scientists for generations. What, if anything, exists at the very limits of all we know? And could there truly be something beyond? To even embark upon this journey, we must first gather all that humanity has uncovered about the universe's grandest scales, vast stretches of cosmic time, unfathomable distances, and the most profound mysteries of existence. Imagine yourself gazing up at the night sky, thousands of tiny points of light, each a vast sun or faraway galaxy. But between the stars is a darkness far deeper than any void we know on Earth. What does that blackness conceal? Is it merely the darkness between points of light, or is it the beginning of something altogether unknown? To answer these questions, our journey must take us back, farther back than any spacecraft has traveled, farther back than the oldest galaxies, to the beginning of the universe itself. Scientists estimate that about 13.8 billion years ago, all that would become the universe erupted outward from a singular, unimaginably hot and dense point. This event, the Big Bang, launched not just all matter and energy, but space and time themselves. At its birth, the universe was a uniform sea of blazing energy, rapidly expanding. Within seconds, simple particles emerged, forming the first hydrogen and helium atoms. Around 380,000 years after the Big Bang, the universe cooled enough for these atoms to capture electrons, allowing light to travel freely for the first time. This ancient light, now stretched and cooled into the cosmic microwave background, is a relic, the oldest picture of our universe, a monumental clue to its origins. Yet even this cosmic glow only illuminates so much. Our observable universe, a bubble around us, defined by how far light has traveled since the Big Bang, stretches for about 93 billion light-years in diameter. Everything we have ever known, every star and galaxy ever discovered, fits within this cosmic horizon. But is this boundary the true edge? To many, the notion of an edge implies a frontier, a place where something ends and something else, perhaps unimaginable, begins. We can stand at the edge of a cliff or at the boundary between ocean and land. But the universe challenges our intuition. Rather than an edge in the traditional sense, the current understanding provided by cosmology is awe-inspiring. The universe is vast, possibly infinite, and without a boundary we can ever perch upon or cross. To comprehend why, we must visit another cornerstone of modern physics, Einstein's theory of general relativity. This theory describes how space and time are interwoven into a single fabric, shaped by the matter and energy within it. The universe, as Einstein described, can be curved and stretched by its contents. Remarkably, this fabric is all there is. Beyond it, there is no outside in the conventional sense, no canvas on which the cosmos sits. Some models suggest the universe is flat, stretching out endlessly in all directions. Others entertain the idea of a universe that curves back upon itself like the surface of a sphere. On such a surface, there is no edge. Travel far enough, and you could, in theory, return to your starting point, although in practice the distances are beyond comprehension. Still, even a closed universe doesn't have an outside in any conventional sense. So if the universe does not have a physical edge, what does lie beyond the boundary of what we can see, the edge of the observable universe? To answer, we must introduce a key idea, the cosmic horizon. Due to the finite speed of light and the limited age of the universe, there is a maximum distance from which light could have traveled to us in the age of the universe. The galaxies we observe at this utmost reach are not at the edge of the whole universe, but just at the edge of what we can see. What then exists beyond? The simplest answer is likely more universe. Galaxies, stars, and cosmic structures continue. From what we can deduce, there is no wall, no abrupt ending, no chasm of nothingness, just more of the same. For all we know, the universe could stretch on forever, with new regions unfolding beyond our ability to perceive them. But let us not be content with simple answers. Instead, let us delve into some of the most exciting frontiers in cosmology. First, there is the question of inflation, an epoch of staggeringly rapid expansion thought to have occurred in the first fractions of a second after the Big Bang. According to the theory of cosmic inflation, the universe ballooned at a rate far exceeding the speed of light, smoothing out its contents and making it vast beyond comprehension. If inflation occurred, and evidence points strongly in its favor, the universe may be so large compared to our observable patch that what we see is just an infinitesimal fraction of a much grander whole. Here, the possibility arises that the universe is genuinely infinite. This idea is as dizzying as it is profound. In an infinite universe, every configuration of matter not forbidden by the laws of physics is realized somewhere. In that immensity, there could even be distant regions, indistinguishable from our own, or so different as to boggle the imagination. In such a universe, our observable limits become a tiny island in an endless cosmic sea. Yet the mysteries do not stop here. Inflation predicts something even stranger, a multiverse, a cosmos where our entire universe is just one bubble among countless others, perhaps each with their own physical laws, dimensions, and histories. The inflationary process, in some models, never ends, but keeps budding off new universes in a never-ending cosmic tree. If true, the realm beyond our observable universe is not only larger than we can know, it may be fundamentally different, not just more stars and galaxies, but other universes with other rules. Are there ways to test such bold ideas? Here, science faces its bravest limits. We cannot see or measure beyond our cosmic horizon. Light from those remote regions will never reach us, no matter how long we wait. We are, by the laws of physics themselves, confined to our observable bubble. And yet, traces of the universe's broader nature might be imprinted in the earliest light we can see, or in the grand structure of galaxies. Scientists scour the skies for clues, a subtle twist in the cosmic microwave background, or a peculiar alignment of galaxies. Some philosophers and physicists propose that even in principle, questions about the cosmos beyond the observable end may be forever unanswerable. Yet the human spirit is not so quickly daunted. The frontiers of knowledge have always advanced by probing the limits, seeing deeper, building better instruments, and asking better questions. Let's return to another profound idea: the shape of the universe. If the universe has positive curvature, it is closed upon itself, like the surface of a four-dimensional sphere. In this view, the universe is finite yet unbounded, wholly self-contained, with no need for an external edge or outside context. If the universe is flat or negatively curved, it may go on forever. Current measurements suggest the universe is almost perfectly flat, but uncertainties remain. There is also the question of the universe's fate. As it expands, what will become of space and time themselves? For generations, astronomers debated whether gravity would eventually halt the universe's expansion, bringing about a reverse Big Crunch, or whether it would simply drift ever farther apart. Observations made at the end of the 20th century shook the scientific world. Distant supernovae appeared to recede faster than predicted, suggesting that not only is the universe expanding, but its expansion is accelerating. The force driving this acceleration is called dark energy, a mysterious component making up nearly 70% of the universe, yet undetected except through its gravitational effects. If dark energy persists, the universe may expand forever, becoming ever colder and emptier as galaxies rush beyond one another's sight. In this vision, the edge of the observable universe will drift farther from us with every passing year. Galaxies currently visible will fade into the darkness, and ultimately, only the nearest stars, and eventually, only our own galaxy will remain visible. But could there be something outside our universe altogether, in a level even more perplexing than other universes in the multiverse? Quantum physics, string theory, and concepts like extra dimensions hint tantalizingly at deeper realities. Some speculative theories, like the idea that our universe is a three-dimensional brain floating in a higher dimensional space, suggest there could exist realms beyond not only our observable universe, but the entire universe as we know it. Could these extra-spatial dimensions harbor other universes, or even represent a reality more foundational than ours? We do not know. Mathematical models predict their possible existence, but direct evidence remains elusive. If proven, it would revolutionize our understanding, not only of what lies beyond the universe's edge, but of space, time, and reality itself. Let's pause to consider an even more mystical possibility, that asking what lies beyond the universe's edge may be akin to asking what is north of the North Pole. In this philosophical analogy, the question presupposes a wrong kind of space, a context that doesn't apply in the universe's ultimate structure. Just as the North Pole is the limit of latitude, not a place beyond which north continues, perhaps the universe's edge is not a frontier one can cross, but a limit to existing conceptual frameworks. Yet humans are explorers, compelled to journey to all frontiers, be they physical, intellectual, or spiritual. Throughout history, every edge has been an invitation, the horizon beyond the known world, the distant mountains, the next planet in the sky. Each time, reaching that edge has revealed a greater mystery. Today, our telescopes and detectors are the ships carrying us across the cosmic ocean. The James Webb Space Telescope, the successors to Hubble, and future observatories peer ever deeper, unraveling the tapestry of the cosmos. With each new discovery, our vision extends, our map of the universe grows more intricate, but the ultimate edge recedes. The universe seems not so much bounded, but boundless. Let us explore one final, mind-bending idea drawn from the extremes of theoretical physics, the concept of the holographic universe. Here, some cutting-edge theories suggest that all the information in our three-dimensional universe could actually be encoded on a distant two-dimensional surface, perhaps even at the edge of the observable universe itself. In this view, reality as we know it is a projection from deeper, more fundamental physics. What does this mean for the edge of the universe? If the universe truly is holographic, the boundaries we perceive may not be the end, but the source of all physical phenomena. Our experience within the universe, our very being, could be the unfolding of patterns on a cosmic screen. As we watch the deep sky, we see galaxies whose light has traveled to us from billions of years in the past. Each observation is a message from the edge of our observable world, a whisper from near the limits of what can be known. The farther we look, the more we are looking back in time, towards the very dawn of everything. Each frontier reached unlocks deeper mysteries, the first black holes, the birth of the very first stars, the subtle ripples in ancient light. These all push us closer and closer to the cosmic boundary. Yet even as we race towards this ultimate edge, the fundamental question remains: is there truly a beyond? In the end, perhaps it is not what lies beyond the edge of the universe that matters most, but the journey itself, the insatiable curiosity, the drive to explore, and the unceasing quest to understand. For the edge is not a place in space, but a limit of knowledge, always inviting us forward. As we conclude, let's reflect on what we have discovered and what mysteries still remain. The universe, to the best of our understanding, does not have an edge as cliffs have edges or oceans have shores. Our observable universe is only a fragment, a horizon set by the limits of light and the age of space itself. Beyond, more of the same, or something infinitely stranger, may await. Whether our universe is finite or infinite, curved or flat, alone or one of many, it is connected by the very questions we ask and the spirit in which we seek their answers. The limits of observation inspire us to dream beyond, to imagine new worlds, to probe the nature of space and time themselves. Every generation pushes farther, building upon the legacy of explorers and thinkers who have come before. What truly lies beyond the edge of the universe? At present, it is a mystery without parallel, a frontier forever out of reach, yet forever beckoning. But in the act of seeking, of questioning, we affirm the most exceptional quality of the human mind, its desire to understand the unknown. So the next time you gaze into that night sky, remember that its darkness is not emptiness, but a canvas for the infinite. It is the invitation of the cosmos, calling us to wonder, to question, to discover, and to dream. What lies beyond the edge of the universe? Perhaps, in trying to answer, we will discover not only the nature of the cosmos, but something essential about ourselves. And now, let us carry this quest onward, with new telescopes, deeper theories, and more boundless imaginations. The journey to the universe's edge is, above all, the story of humanity's endless curiosity, a voyage that has only begun. Thank you for joining us on this journey through the frontier of science and imagination. If this mission excites you as much as it does us, don't forget to like, share, and subscribe to Space Future Now. Together, let's keep pushing the edge of what's possible and beyond.